Welcome to the AI for Career Success video overview by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. In this analysis, we'll be examining the key arguments from Elon Musk's presentation on the Terafab project. Our source is the YouTube video titled Elon Reveals Terafab, Tesla and SpaceX, Full Replay, Becoming a Galactic Civilization, from the channel Solving the Money Problem. It's a fascinating vision that draws a direct line between the future of AI compute and humanity's expansion into the solar system. Right at the beginning, the project is framed with this quote. It's not positioned merely as an industrial or technological goal, but really as a foundational step towards something much larger, enabling humanity to become a multiplanetary species. Now, to really appreciate the scale of this ambition, it helps to have a framework, a way to measure the technological progress of any civilization, including our own. The framework used here is the CardArtesev Scale. It was proposed back in the 1960s by physicist Nikolai Kardashev. And what's interesting is that it classifies civilizations based entirely on their mastery over energy. So, according to the scale, a Type 1 civilization can command all the energy available on its home planet. A Type 2 can harness the entire output of its star. And a Type 3, well, that's energy control on a galactic scale. It's noted, of course, that humanity hasn't yet reached even Type 1 status. So what's the primary barrier to advancing on the scale? The presentation identifies a fundamental physical constraint, one that's rooted in our planet's place in the solar system. This number you see here, this is the fraction of the sun's total energy that actually makes it to Earth. It's a pretty stark illustration of just how small our planet is compared to the immense power of our star. The argument that follows, then, is fairly logical. Since the sun makes up 99.8% of the mass in our solar system, any truly significant, civilization-level growth in our energy capture has to eventually happen off-world. It has to happen in space. But this long-term vision of space-based power runs headfirst into a very immediate bottleneck right here on Earth. And that bottleneck is our ability to manufacture the advanced AI hardware that would be needed to build and manage it all. According to the source material, if you combine all of Earth's current AI chip fabrication plants, together they produce just 2% of the annual compute power that would be required to realize this vision. Just 2%. This chart really puts that challenge into perspective. Our current global AI compute output is about 20 gigawatts. The Terafab project's goal is to produce 1 terawatt. That's 1,000 gigawatts every single year. So we're talking about a 50-fold increase from just one project. The gap is immense. The presentation also makes it clear that while existing partners and suppliers are valued, their maximum possible expansion rate is simply not enough to meet this level of demand. This necessitates a completely new approach to fabrication. Okay, so having defined the problem, the discussion shifts to the proposed solution, a vertically integrated, high-velocity fabrication facility designed specifically to break this very compute bottleneck. And this is the Terafab. It's presented as a collaborative project that leverages the unique capabilities of SpaceX, Tesla, and xAI. The goal, again, is a terawatt of AI compute per year. It's being built in Austin, and the critical enabler for the space-based part of the vision is the massive launch capacity of Starship. One of the key strategic advantages here is its vertical integration. The entire chip development lifecycle, from designing the lithography masks to manufacturing all the way to packaging and testing, is all housed within a single building. This kind of setup creates an incredibly rapid feedback loop. New designs can be conceived, built, tested, and improved at a pace that is, according to the presentation, an order of magnitude faster than current industry standards. And this is where the case is made that as launch costs continue to fall, deploying AI compute directly in space becomes fundamentally more efficient. You have constant solar power, not an intermittent day-night cycle. Energy capture is about 5 times more effective without atmospheric interference, and the hardware itself can be lighter and cheaper without needing to withstand weather. So in the final section, this massive infrastructure project gets connected back to its ultimate intended impact on human society and our entire economic reality. The roadmap presented here frames terawatt-scale compute as the foundational layer. That compute power is what enables advanced AI and robotics on a massive scale, which in turn could create what's called a post-scarcity economy. And that economic shift is positioned as the final prerequisite for becoming a truly galactic civilization.
The presentation concludes with this rather profound vision of the future, one where automated production is so vast that nearly any human need or desire can be fulfilled on demand, which could potentially make our current economic models obsolete. And this really leaves us with a critical question to consider. What are the full societal, economic, and even philosophical implications of a technological leap that could provide functionally limitless computational power? Thank you for watching this overview. This is where we teach you AI and help you get smarter than your competition. If you like these videos, use the QR code at the beginning of this video to buy us a coffee or hire us to coach you or your employees in AI. We also recommend that you subscribe to the AI for Career Success YouTube channel. And please do like, comment, and share this overview to help us reach a wider audience.